Hi everybody. In this video, I'm going to explain what we are going to do, okay, or what we are going to implement in our project, okay, using Contiki Kuja. So, project implementation, part 1, Contiki Kuja. Now, what we are going to implement here means we are going to implement four different scenarios, okay, four different scenarios. In each scenario, we are going to have two test cases, okay, two test cases will be available. Now, I'm going for, okay, one by one. Scenario one, I'm going. So first scenario, if you take, so it is going to be, it is having two cases, test case A, test case B. Okay, what is the test case A and test case B means? So in the first scenario, we are going to take 10 nodes. Okay, only 10 nodes we are going to take, and we are going to take one sync node. So these 10 nodes are the IoT nodes. Okay, we are going to say as modes. And the sync node, what is a sync node means? So this is going to be the border router. Okay, border router. All these nodes, all these all the nodes, IoT nodes, they will communicate with the sync node. Then the sync node will communicate with the internet. Okay, so the individual nodes, they are not going to communicate with the internet. So in the individual nodes, okay, they are called mode, mode. They are going to communicate, okay, with the sync, and the sync is going to be communicating with the internet. So we can say the sync node, okay, node, sync node, or we can say it is a root, okay, the root of this particular network. Now, so I'm going to have 10 nodes, one sync node. Okay, we are going to have. Now we are going to design the topology, okay, by using the Contiki. In while using, okay, while creating the topology, so what I'm going to do means I'm going to keep 50% of the nodes, I'm going to keep inside the radio range of the sync node. So that means 50% of the nodes, that means 5 nodes, they are going to communicate directly with the sync node. Then the remaining 50% of the nodes, I'm going to keep it outside the radio range of the sync node. Okay, so this 50%, they cannot directly communicate with the sync node. Through the other nodes, they are going to communicate. Okay, so here we are not going to have any attack. There is no malicious node. All the nodes are going to be legitimate. Okay, so this is going to be the first scenario, test case A. So why we have to do this means this is the real network. So we are going to see how the real IoT network is working in two different cases. Now let me go for the test case B. In the test case B, you can see the same 10 nodes I'm going to have, one sync node I'm going to have. Okay, I already explained what is a sync node, what is the nodes. Okay, these are all the IoT nodes, and this is the border router. Now what I'm doing means all the nodes I'm putting inside the radio range of the sync node. That means all the 10 nodes now we are going to move. Okay, all the 10 nodes we are going to move in the radio range of the sync node. That means all the 10 nodes, they can directly communicate with the sync node. Here there is no malicious nodes, all the nodes are legitimate. So this is going to be our first scenario. So after completing scenario 1, okay, that means test case A and test case B, we are taking the result. Okay, some statistical data we are going to take. So what is the statistical data means? You can take the power consumption details. Okay, I will show that in the lab part. Okay, I'm going to do it as a lab and I will show it. So power consumption details, number of packets received. Okay, and one more thing is there. Okay, there are three options. We are going to take three diagrams and we are going to compare. So this is going to be the base. This is the reference. Then we are going to include the malicious nodes and we are going to do the remaining thing. Okay, so this is scenario 1. Now I'm going for the scenario 2. So in scenario 2, we are going to have two test case. So test case A, test case B. Okay, so in test case A, what I'm doing means I'm going to take 9 nodes. In the previous one, 10 nodes we have taken, but now I'm going to reduce one node. I will remove one node and I'm going to make this one node as a malicious node. That means 9 legitimate nodes, one malicious node. So this malicious node is going to create the denial of service attack. Okay, so and one sync node we are going to have. Now, in test case A, this one malicious node, okay, I'm going to keep outside the radio range of the sync node. I'm not going to keep it near the sync node. I'm going to keep it outside the radio range of sync node. Okay, so 10% is a malicious node. Why? Because one is the malicious. Out of 10, one malicious node, so 10% malicious node. And this malicious node is going to be outside the radio range of the sync node. If it is outside means it will have less impact. If it is inside the radio range of the sync node means the impact will be more. Okay, so this we have to show. Now I'm going for the case B, test case B. You can see same 9 nodes, one malicious node and one sync node. The same thing will be available. So 10% malicious node, and this malicious node I'm going to keep it inside the radio range of the sync node. So this is going to be the scenario 2. So in the scenario 2, we are having two different cases, test case A and test case B. Now, I'm going for the scenario 3. So in the third scenario, we are going to increase the number of malicious nodes. Okay, so already in the previous case, 9 plus 1. Okay, now 7 plus 3. 7 plus 3 I'm going to use. That means 7 nodes will be the legitimate nodes. 3 nodes is going to be the malicious nodes. Okay, that means approximately 30% of the nodes will be malicious, and all these 3 I'm going to keep outside the radio range of the sync node. Okay, all the 3 nodes, it will be available outside the radio range of the sync node. Then in the test case B, same 7 nodes we are going to have, 3 malicious node and one sync node will be available. So here all the 3 nodes I'm going to keep inside the radio range of the sync node. So this will have more impact comparing with this. Okay, that means the malicious node directly they can communicate with the sync node means it will affect your network. That means it will affect the topology badly. Severely it will affect. Now, let me go to the scenario 4. So in the scenario 4, I'm going to have again two test cases. Here we are increasing the malicious nodes. 5%, sorry, 50%. So that means 5 nodes are legitimate and 5 nodes are going to be the malicious node, and we are going to have one sync node we are going to have. So 50% of the malicious, okay, 50% of the nodes are malicious nodes here. The same thing in the second case also. But here what I'm doing, all the 5 malicious node, I'm going to keep it outside the radio range of the sync, and here I'm going to keep inside the radio range of sync node. So here this is going to have more impact. Okay, test case B is going to have more impact, and we are going to evaluate, okay, the result of all these cases. So, okay, scenario 1, scenario 2, scenario 3, scenario 4. So in every scenario we have two test cases. So for all these things we are going to have a comparative, okay, so which is having more effect on the network. So this is what we are going to do as a part 1. I'm doing it, okay, practically I'm going to do it by using the Contiki. Okay, you can implement the same thing in the project. Now, I'm going to show the first scenario, okay, scenario number 1. Okay, so how to do it. Now, I'm going for the terminal, cd Contiki 3.0. Okay, so this is a keyboard mistake. You can change the keyboard English. Okay, so Contiki 3.0. So I'm going for cd tools, cd Kuja. Okay, and run. So now I am inside the Kuja simulator now. So we are going for the first scenario, test case. Okay, test case 1. Okay, we are going for the test case A. Okay, so now let me show that PowerPoint to you. Okay, so this is test case A, 10 nodes, one sync node, 50% of the nodes inside the radio range, 50% of the node outside the radio range. Okay, so no malicious node. So this is our first scenario. Okay, we are going to implement now. So I'm going for the simulation, or you can go for the file, new simulation. Okay, you can give the name. I'm giving scenario 1 and test case A, TA. Okay, you have to save it. You have to save it because you are going to, okay, show this in the exam. Okay, you're going to show it in the exam. So you have to save it and keep it with you. Now, so scenario 1, test case A. So radio medium, we are not going to change the radio medium. The radio medium is going to be the same. That means UDGM. Now I'm giving create. Okay. Now you can just adjust the screen sizes. This is depending upon your monitor. You can adjust the screen size and always keep more space for this. Okay, network. That means the topology. Here your topology will be available. So give more space for this. Now, so what is our test case means? You have to create one sync node and 10 UDP sender. Okay, UDP sender nodes. So now I'm going for modes, add mode, create mode, okay, sky mode. So I'm going for the sky mode. So here, let me select the UDP sender first. So I'm changing the name. So what is the name means? UDP sender. Okay, so this is going to be your IoT nodes, or we can say IoT modes. So UDP sender. So here, what is a program I'm going to load means I'm going for the browse. So let me go for the Contiki 3.0. In Contiki 3.0, I'm going for the examples. So these examples, in that you can go for the IPv6 in the RPL collect. In RPL collect, you can take, okay, UDP sender. Okay, UDP sender.c, and you can just open it. Now, I'm just giving compile. You can give clean and compile. Okay, that will be always better. Okay, click the clean and compile. So I compile. I'm going to create the UDP sender. So how many nodes you want to create means I want to create 10 nodes. Okay, so the number of new nodes equal to 10. So 10 nodes I want to create. Now I'm just going to add it. So all the 10 nodes is available here. Then I'm going for the modes. I'm going to add the mode. Now already UDP center we already have. So I'm going for create new mode. I'm going for the sky mode. So here this is going to be the sync node. Okay, sync node. This is called the root. Okay, this is a very important one. All your devices, that means all the devices, these 10 devices, they are going to communicate with the sync node only. So I'm taking the sync node. So just browse, same in the RPL collect. You are having the UDP sync.c. Okay, UDP sync.c, and just give open. You can just clean and compile it. Okay, so compilation is over. Now I'm going to create. So how many nodes means you need only one sync node you need. So I just created the sync node. Now it is not properly arranged. So what you are going to do means go for the view, go for mode ID. Okay, so this is ID is very important. Then only you can find the numbers. Then the next one very important thing is, so no need to take the IP address and all. You can take the radio traffic. Then I'm going to take the 10-meter background grid. Okay, this is very important. Okay, so 10-meter background grid, then mode type. Okay, mode type I'm going to take. Then if you want to take attributes and all, you can take it, but this is enough. Printf statement also I'm going to take. Okay, this is now you can zoom. You can just zoom in or zoom out. You can adjust the position. Okay, what is that means? Your topology should be in only one grid. Okay, only one 10 into 10. This is the 10 meters, or so this is 100 meter. So 100 meter into 100 meters. Okay, your topology should be arranged in a particular box. So this is going to be a simulation area. So here what is the simulation area we are selecting means we are selecting 100 meters into 100 meters is the selection, is a radio range we are going to take. So your all your devices should be arranged only in one box. Okay, if you count here, You'll take, okay, you'll get 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one is, okay, it is going to be the 10 meters. So 10 meters, 10 meter, 10 meter, if you count, this is going to be the 100 meters from here, and this is going to be the 100 meter. So our topology, that means our network, we are going to arrange in a area of 100 meter into 100 meter area. Okay, so this is very important. Now, in this, I'm going to keep my sync node. The sync node should be in the middle, in the center. Okay, the sync node should be in the center. You have to arrange it in the center. Now, if you click the, okay, if you click the sync node, you must know the radio range. So you go to the view and you can click the radio environment. Make the radio environment on. Now you can see it is perfectly available. Okay, no, it is not perfectly available. You have to move like this. Now, okay, you can see your radio range is exactly, it is matching in the 10 100 meters 100 meter area. So I kept my, okay, what is this? This is a sync node. I kept it exactly in the center point. Now, what is our first case? Okay, if you see what is the first case means, the first case is going to be, okay, 10 nodes. Okay, you can see scenario 1, test case A. 10 nodes already created, one sync node we created. Now 50% of the nodes inside the radio range of the sync node and 50% of the nodes outside the radio range. Okay, now I'm going to move, I'm going to arrange. So how I'm going to arrange means 50% should be available inside the radio range and 50% should be available outside the radio range. So now you can see, so this is 50% means 5 nodes I'm going to move outside the radio range. Okay, now you see this is first node. Okay, you click on the 11. Okay, you see this is outside now, 8. Then here 10 is available, 10 also I'm going to move it outside. Okay, then we have 3, so I'm just going to have 3 here. Okay, you may get a different topology, you are not going to get the same way, but you have to rearrange it. Okay, your topology you have to rearrange. So 4 also I'm going to keep it outside. Okay, and here I have 5, so 5 also I'm going to keep it outside. So what we am doing now, so totally 5 nodes I kept outside the radio range of 11. The remaining 5 nodes, they are available. Okay, they are inside the radio range of 11. Okay, 1 2 3 4 5. So here 1 2 3 4 5. Yes, so here also if you want you can just arrange, okay, randomly you can move the position so that the nodes which are available outside they can communicate. So now you can see I just click 11. So 1 2 3 4 5. So 5 nodes inside the range of, inside the radio range of 11 and 5 outside the radio range of 11. Okay, so this is our first test case. In the second test case, what I'm doing, I'm going to move everything, okay, inside the radio range of 11 and I'm going to check the topology. Okay, so now you can run the simulation. Okay, you can run the simulation. So I'm just going to click start. Okay, I'm just click the start. So it started, the topology is started. So it is printing the message. Okay, you no need to have the message. So I'm going to remove, okay, the printf I'm going to remove. So now they are going to communicate. Okay, so what I'm going to do next one, I'm going for the tools. Okay, I'm going for the tools. I want to collect the view, collect the data. Okay, I want to collect the data. Now always we are going to collect the data for the sync. Okay, because sync is going to be the root, so the impact on the sync only we are going to calculate. Now I'm going to collect view, go to the sync. Okay, that means the node 11. Okay, the sky mode 11 is the sync, so I click the sky mode 11. Okay, I click the sky mode 11. Now I have the sky mode 11 here. Okay, that means the collect view is available here. So what you can do means you can adjust the interval. For all the scenarios, you can adjust the interval. Okay, the report interval, you can make it 10 seconds. Already 60 seconds is there. Okay, 60 seconds means it will take a lot of time. Every 60 seconds only they will collect the data. So you will not have more data here. So I'm going to change 10 seconds, 10 seconds I'm going to change. Okay, the report interval 10 seconds, report randomness 10 seconds. Then I'm going to click the start collect. Okay, so click the start collect. Then you can give send command to nodes. Okay, send command to nodes. So if you click that, now your device started collecting the data. Okay, that means your sync node is collecting the data. So now I can go for the network graph. Okay, you can see the network graph. All the nodes are connected with 11. Okay, all the nodes are connected with 11. So 11 is going to be our root. Okay, you can see here 11. So 7 and 5 is connected like this. So with 11, okay, 1, okay, and 4 is connected like this. So all the nodes are connected with 11. That means our topology is working fine. Now you can go to the next one. Okay, so now wait for 5 minutes. Okay, don't go more than that. You can see here already it is showing 6, but this is not exactly the minutes. It will go very fast. Okay, it is not the minutes, it is some internal clock they are calculating. So what you can do, you can go for, okay, okay, see, I'm in this place. You can go to the, okay, node information. You can go to the node information. So in the node information, you can see the timing will be available. Okay, timing will be available here. So what does that means? Already 4 minutes, okay, 12 seconds is over. So here, just wait for 5 minutes or 6 minutes. Okay, don't wait more. Okay, why means if you follow a particular time here, you have to do it in all the machines the same thing. If you're waiting for 10 minutes, do for all the scenarios 10 minutes. Okay, so whatever the time duration you want to fix. Okay, otherwise I will just go here. You can see here. So here I want to wait up to 15. Okay, so 15 minutes. Okay, for example, I'm taking. So up to 15 I want to wait. Okay, please wait. Once it reaches 15, you can start collecting the data. So do it for all the scenarios in the same way. Okay, you can follow any place. Here for, okay, 4 minutes they are showing. Here it is almost 11 minutes they are showing. So you take any one. Okay, you take any one. So either here or here. Minimum, okay, you have to take at least, okay, minimum 5 minutes. If you here my 5 minutes is enough, but here if you go at least 10 minutes you have to wait. So after 10 minutes, okay, 15 minutes, like that, any particular duration you fix. After that, you can start collecting the data. Okay, now, so in this case, I'm going to follow this. So here, I'm going to wait for 5 minutes. I'm going to wait. So after 5 minutes, I'm going to start collecting the data. Okay, so now you can see here. So here it is showing 4.12. Okay, 4.1. Okay, 12. That means 4 minutes and 12 seconds it is showing. Now just wait until it becomes 5 minutes. Okay, I'm going to wait until it becomes 5 minutes. Then I can stop the scenario, that means my simulation, and I can start collecting the data. Okay, so I'm just waiting. So let it comes. So after, in between, I just go and see the remaining, okay, whether power is there, okay, network, sensors. So everything is available, everything is working properly. So we kept 50% of the nodes uh, inside the sink, that means the radio range of the sink. Okay, and 50% of the nodes we kept outside the radio range. Okay, so now it is working, it is properly working because we don't have any attackers here. So this is a normal, okay, diagram, normal topology diagram. So just wait for another few minutes. Here it takes time. Okay, you can see if you go to the node information, it takes time. Okay, it is showing it stopped only in 4.2. It will change, but it will take time. So I will follow this. If it reaches 20 here, I'm going. Okay, if it reaches 20 here, I'm going to pause. Okay, if it reaches 20, you follow the same thing for all. Okay, same topology for same timing. You can do it for all the topologies. So here I'm going to fix 20. Whatever it comes, that is going to be the 20 I'm going to fix. But here you see it is taking a lot of time to change. Okay, you can follow any one, that is my point, but it should be uniformly followed to all the topologies, all the scenarios. So now once if it reaches 20, okay, 20 minutes, it is not 20 minutes, it's less than 20 minutes only, but anyway, so this 20 minutes if it reach, I'm going to pause. Okay, let me pause the topology and I can collect the data from this. Now it reached 20, so I just simply I click pause, I stop the simulator. Now I'm going for the here. Okay, I'm going for the what is it, the collecting the data. Now I go to the sensor map first, so no need to take anything from the sensor map. Okay, network graph also we no need to take, but I'm going for the sensors. Okay, sensors is very important. Okay, now you can see I have temperature. Okay, so temperature, average temperature, temperature, battery voltage, battery indicator, relative humidity, light 1, light 2. There are so many things available for sensors. So don't take everything. Okay, don't take everything. You can take only the average temperature you can take. So that means what is the temperature of, okay, node 1, node 2, node 3, node 4, node 5 after running the simulator for 20 minutes. Scenario 1, test case A. Okay, now this is I'm going to take, you can simply right click and you can give save as. Okay, so let me just give save as. So I'm going to save it in the desktop. Okay, I'm going to save it in the desktop of your machine. Okay, of your Contiki. Okay, now I'm fixing the name. So what is the name means? This is the temperature and this is the average temperature. So AVG. Okay, you can give the name because this you have to include in your report. Okay, in the report we have to add all these things. So average temperature TEMP. Okay, so before that I'll write it scenario 1. Yes, 1, scenario 1. Okay, so test case A. So for test case A, okay, the average temperature is this. Okay, average temperature is this. I'm just going to save it. So I'm in sensors. In sensors, I'm going to take only the average temperature I'm taking. So the remaining thing, okay, no need. Okay, it will be if you collect everything, then it will be a huge thing. No need. So only sensors, average temperature. Then, so let me go to the network. So in the network, there are plenty of options available. Plenty of options available. So now I'm going for, okay, received. Okay, that means average packets received. That means how many packets it is received means that means the 11, okay, from 11 nodes, how many packets received? That means your sync node. So the sync node is receiving 23 packets, okay, in this 20 minutes. If you go for the attack, scenario 2, scenario 3, scenario 4, if you see, the number of packets will increase. Okay, it will increase. Now in this case, only 23 packets it is received from 11 nodes. So now I'm going to save this, save as, okay, in the desktop. I'm going for the desktop. So what is this file? So this is scenario 1, test case A. Okay, this is packets received. Packets received. Okay, packets received. So I'm just going to save it. So this is the second set of data. Okay, we collected. Then you can just go through the remaining thing. I'll show it one by one. So lost, no need, received packets. Okay, if you want, you can take this one. This is also important. This is the total number of packets, and this is going to be every node. Okay, so for every node. So received per node. So node 1 received 2 packets. Node 2 received 3 packets. Node 3 received 2 packets, 4 packets, 5 packets. Node 6 received 4 packets. Okay, so here each node, how, okay, for each node, how many packets it received, it is showing here. The previous one, sync node, how many packets it's received. Now, if you keep this, if you see in the attacking scenarios, any one or two nodes will get more number of packets from the attacker. Okay, we are going to compare like this. So now let me save this. I'm going to save it. So I'm going to save it in the desktop. So what is this means? This is going to be scenario 1, test case A, test case A. Okay, and this is going to be packets received. Okay, packets received, already I gave packets received. Okay, packets received per node or received per node. Okay, you can just change the name as you like, but you have to collect the same data for all the topologies you have to collect. So received per node. Okay, received packets per node. Okay, packets per node. So this is the second, okay, the statistic data we are collecting here. Then The next one, okay, received 5 minutes, okay, routing, all these things you no need, okay, you can just leave it, okay. So in sensors we collected one, in network we collected two, okay, two statistical data we collected. Now I'm going for the power. So power is going to be very, very important one. So in the power, okay, you can see I just go to the power. In the power, average power, okay, this is average power consumption by each node. Okay, if you take node number 1, how much of the power it is consuming? Node 2, node 3, node 4, node 5. Okay, this is going to be the power consumption. So this is very important. I'm going to save this in my desktop. So scenario 1, okay, scenario 1, test case, okay, test case A, for test case A, and this is going to be the average power consumption. So average, okay, average power consumption, okay, average power consumption. So this is very, very important. Now, in the power consumption itself, you can see the radio duty cycle, instantaneous power, and power history. So this is no need. Only average power consumption, if you take it, is enough. So this will give everything. All the 4 types of powers it is giving. Okay, LPM, CPU, okay, radio listen, and radio transmit. So these are the 4 different types of power a device will use. Okay, so one is the LPM, second one is the CPU. CPU power means, that means which is running the CPU. So CPU power, radio listening power, transmitting power. So here mostly they consume for the listen only. Okay, so this is. Then we have the node information. So this is okay. It is not changing. It will change, but it will take more time. You have to wait for a very long time. No need. You can follow this particular timing. Okay, in the simulation control, 20. Okay, 20 minutes. Okay, make it as 20 minutes. This is, you can wait up to this. It is enough. So next one is a serial control. Okay. So we collected, I repeat, we collected in the sensors, we collected the average temperature. Then in the network, we collected, okay, the total number of packets received by the sync node. Then the packets received by each node. Okay, so this is the third, okay, graph. That means we collected. Then the fourth one, it is going to be the power consumption details. So power consumption details we collected. So now your simulation is okay. The results also you collected. Now I'm going to close this. I'm going to close this. And very important thing, you have to save it. If you are not save, okay, if you forget to save, problem. So what I'm going to do means I'm going to save this file, save simulation as. Okay, in the desktop, I'm going to save it. Okay, in the desktop, I'm going to save it. So this is scenario 1. Already we gave the name, but I'm going to save it in the desktop. Scenario 1, test case A. So TA, test case A, I'm going to save. So now let me just save it in the desktop itself. Okay, so the simulation is over. Now I'm going to close the simulation. Okay, do you want to save this? Means yes, I want to save. Okay, again it is asking us. So test case 1, sorry, scenario 1, test case A. I just selected. I'm going to save. Let it be overwrite. Okay, now you can see, okay, your data, whatever the data you collected. Okay, so this is the data we collected and our scenario. Okay, that means our simulation is available here. Okay, this is the simulation. So I'm going to make it file. Okay, that means a folder. Okay, so project. So let me put everything inside this particular folder. Okay, so I'm going to add everything inside this. Let me add everything, okay, inside this particular folder so that it will be easy to handle. So test case A, scenario 1. Okay, so this is now 1, 2, 3, 4 data we collect. So what you can do now, for a time being, you take that PowerPoint presentation. I will send the PowerPoint to you. In the PowerPoint, you insert all these things. Okay, you can copy this to your pen drive, come to Windows. In Windows, open the PowerPoint presentation. Okay, so enter first, okay, scenario 1, test case A. Enter all the 4 results in 4 slides. Okay, this is going to be an image file. This is an image file. So the image file you can open, okay, you can use it anywhere, either in the Windows or anywhere. You can use it in the Word document, you can insert this. Okay, so this is going to be the case number 1. Now, second case, okay, I'm not going to do it. You can do it by yourself. Okay, why means in the second case, same 10 nodes you are going to have. Okay, I'll show the second case for you. In the second case, that means test case B, same 10 nodes you are going to have. In that, you are going to keep all the nodes inside the radio range of the sync node. Okay, you can move everything inside the radio range of the sync node. So here there is no malicious node. You don't have any malicious nodes here. Okay, so this is going to be the scenario 1. Now I'm going for scenario 2. Okay, scenario 2 I'm going for. So scenario 2 I will implement, but in scenario 2 we are having the malicious nodes we are having. Now I'm going for scenario 2. In the second scenario, 9 nodes I'm going to have. 9 nodes I'm going to have. One node is going to be the malicious node, and one node is going to be the sync node. And this sync node, okay, I'm going to keep it outside the radio range of the sync node. I'm going to keep it. So now let me go to the config key, go to the terminal. Already it is available already in the terminal. I'm going to give the command and run. Okay, I'm going for the puja. Now I'm doing second scenario. Okay, first scenario test case A I have done, B I have not completed. You can do it. So I'm going for second scenario test case A. Now I'm going for file, new simulation I'm creating. So this is going to be scenario 2, S2, test case A. Okay, test case A. Now you can adjust the window size. You can adjust the window size. You can adjust the window size. So this is the okay. Now I'm going for the modes, add mode. So create mode, sky mode. Okay, so now this is going to be the UDP sender. First, always make UDP sender. Okay, so UDP sender I'm taking. Now the process is going to be the UDP sender.c. Okay, this is the C program. Already it is available. Okay, you no need to take it. If you want, I will show it again. Contiki 3.0. In Contiki 3.0, I'm having examples. So in examples, okay, go for IPv6. Go for IPv6. In IPv6, okay, RPL collect. Okay, in RPL collect, okay, we are having the UDP sender.c. Okay, I'm just going to open it. Now you can clean it and compile it again. Compile it. Now you can create. So create, how many nodes you want to create means, in this case, I want to create 9 nodes I want to create. So I'm giving 9. Then I'm just going to add mode. Add modes. So 9 modes created here. Then the next one is I'm going to create mode, add mode. Already UDP sender 9 we created. Now I'm going to take sync mode. So here I'm going to take, okay, this is going to be my sync. Okay, this is going to be sync. So I'm going to browse. So sync, okay, UDP sync.c. I'm taking UDP sync.c. Okay, so clean and compile. Clean and compile. Okay, so now I'm going to create only one sync. I'm going to create. Try to note down. Already 9 nodes we created. So 1 to 9 is created. This is going to be 10. Okay, this is going to be 10. So 10 is your sync node, sync mode. Okay, so I'm going to create one mode. Okay, just add one mode here. So 10 is going to be your sync. Now the next one, I'm going to add the attacker here. Okay, I'm going to add the attacker here. Now I'm going for the modes, add mode. So already UDP sender, okay, 1 to 9 we already added. Sync is going to be the 10. Okay, that means the mode number 10 is the sync. Now I'm going for create new mode. I'm going for the sky mode. Okay, click the sky mode. Now this is going to be the attacker. Now I'm just writing, this is the attacker node. Now you can browse. already I sent the file. Okay, I sent a file to you. That means two files I already sent to you. One is called the attacker.sky and another one is called the make file. So I already copied this UDP sender flooding attack.sky. This file I copied in this folder. So which folder it is? The folder is, okay, you can go to the Contiki 3.0, okay, in home, user, Contiki 3.0, in Contiki 3.0, okay, here we have examples. In examples, IPv6, okay, IPv6, in IPv6 RPL collect. So in this RPL collect, already I copied this file, okay, UDP sender flooding attack.sky. Okay, make file also I already sent. If you copy the make file, if you are not copying the make file, okay, it doesn't, it's not making any change. Okay, but this file, it should be saved here. UDP sender flooding attack.sky. Now I just open this particular file. Now you can see here the compile option is closed. You cannot find the compile option. Okay, why? Because this file I already created, I compiled, there is no error in that. Okay, and I'm giving this file to you. After completing all the scenarios, I will give the code. Okay, the code for this. You have to insert the code in your document. So now it is not showing any compile. You can just simply create it. Okay, you can just simply create it. So how many attackers you want to create means, in this scenario I want to create only one attacker. I just give only one and I'm going to add mode. So attacker is now created. Attacker is 11 now. Okay, attacker is 11 now. So now you have to arrange it. So why we have to arrange? You can see our topology, our scenario says scenario 2 test case A, 9 nodes we already added, one malicious node we already added, one sync node we already added. Okay, now the okay, 10% is the malicious. Out of 10 total, 10 more nodes, one is malicious, means 10% is malicious. Okay, this node I'm going to keep it outside the radio range of the sync node. Okay, I'm going to keep it outside the radio range. Okay, now so let me go here. So first what I'm going to do, let me give view mode ID, then okay, radio traffic, then you have to take the grid. Okay, 10 meters background grid, then okay, mode type, then okay, radio range. So these are the things you have to take. So now you can see this is our sync, 10 is our sync and 11 is going to be the attack. Now you can just go for okay, zoom out, because you have to arrange it into 100 meter 100 meter, okay, area we have to arrange it. So now, so these are all our nodes. So now the sync node I'm going to keep it in the middle. Okay, you can see the box. So this is the box, 10 meter, sorry, 100 meter 100 meter box. So in this I'm going to keep it, my sync node I'm going to keep it inside. Okay, that means I'm just keeping it, okay, I'm arranging like this. Now so the attacker, you should not keep it inside. In this test case you are going to keep the attacker outside the radio range of your sync. Then the remaining roads you can arrange like anything. Okay, you can arrange in any way. So I'm just arranging like this. Okay, some nodes outside, some nodes inside. Okay, like that. So here, if you see, the attacker can attack 4 and 6 only. Attacker cannot directly attack the sync node. So only 4 and 6 is going to be affected. So while you are designing, you may get a different output. Okay, you're going to arrange in a different way. Okay, you can have, okay, so this is the concept. So my attacker is outside now, so the simulation is ready. Then you can start the simulation. Okay, start the simulation. Then you have to start collecting the data. Now let me go to the tools. So in the tools collect view, you have to go to the sync node 10. Try to understand. Sync node 10, 11 is attacker. So for 10 only we have to take, because 10 is going to show the entire network. So because everybody will communicate with the 10. So I'm taking sync node 10. So you are having the control here. So this is going to be the simulation control. You can change the time, the interval time you can change. So 10 seconds and then report randomness 10 seconds. Okay, you can click the start collect and give send commands to the nodes. Okay, I'm giving send commands to the nodes. Now you can see already, okay, it is started. I already told up to 20 minutes we are keeping here. So just wait for, okay, 20 minutes. Then you can start collecting the data. So if you want to check whether the topology is working or not, you can go to the, okay, networks, okay, not networks, you go to the sensor map and you can check. Okay, all the nodes will be available, and also in the network graph you can see. So it will take some time, okay, to settle down. So you can wait until, okay, 20 comes here. Then you can start collecting the data. You can pause the simulator and you can start collecting the data. Let it be, okay. So I'm just going to wait, okay, and I'll show how to collect the data. Comparing with the previous topology, okay, comparing with the previous topology, so this will take some time, okay, because here we included the attacker. Okay, you can see to form the network graph itself, it is taking some time. So, okay, it takes some time to, okay, still it is not connected. You can see the remaining things are not connected. So it will take some time here because we are having the attacker here, one attacker. So what you can do means instead of 20, you can make 25 minutes also you can wait. Okay, so that is the thing what I want to say here. You can use, you can wait up to 25 minutes also you can wait. Okay, there is no problem. You may get the proper result. To get the proper result, okay, you can wait even for the 25 minutes you can wait. Once if the number of attackers are increasing, okay, so there will be some delay in your okay, the what is it, the result. So you may not get the results immediately. Okay, so it will say take some time. Okay, you can see the sensors. So sensors only, okay, average temperature only for 1 2 3 4 5 nodes is coming. Okay, so it is not showing for all the nodes, but it will show, but it will take time. You have to wait. Okay, you have to wait. Once if you are seeing for all the nodes, okay, you can stop the simulation and you can start collecting the data. You can follow the time. If you're not following the time is also okay, but what is that means, you need to collect the data for all the nodes. Okay, you see, let me go to the power. In power you see only for the two nodes, sorry, 1 2 3 4 5, only for the 5 nodes, okay, we are showing, okay, it is showing. You have to wait until for all the nodes the power is coming. Okay, now you see 4 and 6 is consuming too much of power for listening, okay, because they are under attack. Okay, they are under attack. So in your report you have to take the print screen of your topology also. This also you have to show. Okay, your topology plus another 4 results. Okay, another 4 results you have to show. Now you see one by one is coming. So 1 2, okay, 4 5 6. Okay, the remaining thing is not coming. You can wait. Okay, so if you're not following the time also, there is no issues here, but wait until all the nodes are displayed. Okay, that is very important. Okay, sometimes it may take more time, sometimes it may take less time, This is depending upon the machine that you are using. Okay, now you can see the power. Then I go to the network. You can see the received over time. So only 11 packets it is showing received per node. Okay, you click the received per node. Okay, you see all the nodes are not available here. So 1 is available, 2 is available, 4 is available, 5 is available, 6. Okay, 6 is available, 9. The remaining thing is not coming. So one by one it is creating, it is generating. You can wait until that you see 6 is under attack. Okay, 6 it is receiving more number of packets. Okay, this is the denial of service attack. It is receiving more number of packets. Okay, and now it is increasing, and power also it will come. So you have to wait until it shows all the nodes. Then you can right click and you can save the pictures. So for every topology, that means every scenario, we have every test case. In each test case, you have to include the picture. Okay, the picture of this. Okay, you can include the picture of this. Plus, you have to include the 4 pictures. Okay, what is that? Go to the sensors, take the temperature. Go to the network, take the packets. Okay, how many packets received? Then received per node. Okay, received per node. Go to the power and take the average power consumption. Okay, still not showing failed. So what you can do, you have to divide the topology among yourself. You can divide the topology and test case you have to divide. I forgot to tell you how to take the screenshot of this also. Okay, for every scenario, the topology also important. Okay, so totally there will be 5 diagrams for every test case. Okay, if you take first test case, the topology diagram plus four results. Second, okay, the same thing, you have to take the print screen of this, and you have to take the output. So in this way you can proceed. Okay, you can go for the every step. Okay, so the remaining instructions I will send it by the WhatsApp. Okay, so just simply right click and save it. You can save it and you can collect the data like this. So I don't want you only one student doing everything. Okay, the remaining thing including no. So okay, all everybody must share this. If you have a more powerful computer, for example, if you have the high ram, more ram, you can go for the last one. Okay, so don't fix any particular time. For only for first scenario you can fix the time. Okay, 20 minutes or 30 minutes, whatever it is. But for the remaining scenarios, please try to collect for all. If it is showing all the nodes, finished enough. Okay, you can just right click and copy it. So teacher will it shows all the nodes, definitely it will show, but some time it will take. Okay, it will take some time. So after once, okay, if you are seeing all the nodes, enough, you can stop this now. Okay, your simulation, just go to the simulation and you can simply pause the simulation and you can copy it. Okay, so this is what we are going to do. Okay, so I want this work to be completed by next week. Next week we are going for the next concept, that is going to be the machine learning. Okay, that is going to be a very easy, some data set we are going to download, and okay, which is related with this uh, Contiki, and we are going to do the analysis in that. So with that we will finish the project. This is 50% of the implementation will be over if you complete this. So I want this to be completed by next week without any excuse. Okay. All the simulations, it should be ready in your, okay, with you, because in the exams you have to show it. Okay. In the, what is that? In the Viva, you have to run your simulators and you have to show it. Okay. So I think you understand what we are going to do. So please do this for all the scenarios. Thank you.